In this session, we will see how Arduino microcontroller can read digital input using digital read function. For the digital read function, in order to receive the digital input, I'll be using a switch. The switch is connected to pin number 12. So I will set up pin number 12 in input mode to receive a digital input, either high or low. So there is a switch here, and I'm going to use a push button which is shown here. So when the switch is pressed, in this case, pin number 12 gets low because that gets connected to ground. Now this is one way of connecting a switch. Switch can be connected between pin number 12 and ground. And then you have a resistor, 10 kilo ohm resistor, which is called as pull-up resistor because that is connected between pin number 12 and high, that is 5 volt. In Arduino microcontroller, when it is powered, we get 5 volt, and the same 5 volt can be used here. There is another way to connect the switch. Squish switch can also be connected between 5 volt and pin number 12, and then you can have a resistor between 12 and ground. We know that the Arduino microcontroller has several ground pins. So ground is nothing but where the voltage level is zero, or we call it as low. So both circuit will work in this case. Now the first case, if the switch is closed, pin number 12 gets low because that gets connected to ground. So pin number 12, when it is set up in the input mode, it receives a low signal. When the switch is open, pin number 12 gets connected to 5 volt through this pull-up resistor and it gets high. Whereas in the second case, if the switch is closed, then pin number 12 gets high. When it is open, it gets connected to ground, that is 0. So pin number 12 gets low. So depends on the application, we can choose any one of the circuits. Before we rig up the physical circuit, let us simulate using Arduino. My circuit is ready. So this is the push button which is connected between pin number 12 and ground. This is my ground terminal. Then there is a pull-up resistor which is connected between pin number 12 and plus 5 volt. I get 5 volt from this pin of Arduino. So this is my simple circuit. When the switch is closed, pin number 12 gets connected to ground. That's how pin number 12 receives low. When the switch is open, the normal it is open. When it is open, pin number 12 gets 5 volt through this pull-up resistor. That means pin number 12 gets high. Now let us focus on the Arduino program. So this is my Arduino program. So let us analyze the Arduino program. Under setup function, I have pin number 13 and 12. Pin number 12 is used in the input mode to receive the digital input, high or low, depends on the switch status. I will also use pin number 13 to display the status of switch. So we know that there is a built-in LED, and I'm going to use pin number 13 in the output mode to display the status of pin number 12. So this is my setup function. In the loop function, a digital read to get the digital input status, whether it's high or low, and that's going to be stored in a variable VAL. So this name can be anything. I'm just giving this name, and this has to be defined in the beginning. So this is the way you can define. You can give integer because this has to take 0 or 1, depends on input status. If pin number 12 is low, then it takes a value 0. If it is high, it takes a value 1. So this value will be either 0 or 1. And I'm going to write this to pin number 13. So if this is 0, then pin number 13 LED will be off. If this is 1, then pin number 13 LED will be on. Now whenever we have a digital read function to read the switch status, to make the circuit free from any kind of noise or bouncing effects, we introduce a delay before we read again, because this is a loop. It's a continuous loop. So before we read the status again, we need to introduce a small delay. That is for stability. So 10 millisecond is more than enough. So this is my program. Let me start the simulation. Now you can see that normally when the switch is open, when it is not pressed, pin number 12 gets high. That means VAL will be high, VAL will be high. So pin number 13 gets high and the LED is on. When I press the switch, you can see that as long as I press the switch, this pin number 12 gets low because it gets connected to ground through switch. And because of that, this variable will be 0 and pin number 13 gets low. So therefore, LED gets turned off. Now let us focus on the physical circuit. So I have written a program using Arduino IDE, the same program what we just discussed. Let me verify the program. So it's already verified, it's compiled. Before loading the program, let me just check the connections. So board has been selected, port also has been selected. So I can just load the program into the microcontroller. It is loading the program and uploading is complete. This is the circuit. This is the circuit which I have rigged up. There is a switch which is connected between pin number 12 and ground, and pull up resistor between pin number 12 and 5 volt. I get 5 volt from Arduino pin. So this is my circuit. I have already loaded the program into the microcontroller. According to that, normally when the switch is open, the LED glows. LED which is at pin number 13, you can see that it is glowing. Now when I press the switch, the LED turns off because switch connects pin number 12 to ground. Now I have modified the circuit. I have rigged up this circuit. You can see that the switch is now connected between pin number 12 and 5 volt. This is my 5 volt. The switch is connected between pin number 12 and 5 volt. And pull down resistor I have this resistor which is connected between pin number 12 and ground terminal. This is black is my ground terminal. So this is the one. Because of this, the normally when the switch is open, then pin number 12 gets connected to ground through the pull down resistor. When I press the switch, you can see that the LED glows because switch connects pin number 12 to 5 volt.